As promised, I'm doing a short video, I hope short, on the use of the binomial lattice idea. So I'm going to review this once again. You have the slides, okay? So I'm going to use the garage case and actually implement this using some fake data. Okay, so here's the base case, and I called it base case pretty because I've got all these fancy formatting and stuff going on. But this is the one that I described in the last video. I've got the variation in demand, right? And this is the base case where there's a fixed number of levels, okay? And I've already gone through all of this. I amortized the capacity cost over the 15 years, and came up with a net present value. So in this case, I only have one uncertainty variable, which is the demand, right? And I've introduced the random number generator for that. I could use and did use the Monte Carlo method to generate a bar curve for this setup. Okay? Now that's great, but if I want to introduce a richer evaluation, I can choose another uncertainty variable and introduce a binomial lattice. So what I'm going to do here is use this annual revenue and vary that. So it's a market price that I can charge, so that affects my revenue. And I want to know what happens if this goes up or down throughout the years. So what I need to figure that out is to find some historical data. So I have some made this, a binomial lattice. So those are the values that I'll use in creating that. It's driving me crazy here. Hold on. There we go. So now all I'm doing here, so I have the original setup up above. All I'm doing is scrolling down and introducing a bunch of stuff for the binomial lattice calculation. So the starting price, $10,000. That was the value that I had originally. V, notice, is 5%. Sigma is 10%. I'm going to use a delta T of 1 year. If I use something different, that will change the numbers, right? But this is the sigma for 1 year. Okay. So the upside factor is the E to the sigma times the square root of the period of years that I'm going to use, right? So, you know, if I wanted to use, let's say, a time interval of 5 years, I would only, for a 50-year period, I only need 10 intervals instead of 50 intervals. Using a binomial lattice, you want to try to keep the number of intervals, you know, fairly low, and you'll see why in a few minutes. Okay, so the upside factor is e to the sigma times the square root of the delta t, which is often just 1 year, but sometimes it's more. And then the downside factor is just 1 over the upside factor. Okay. So to create the binomial lattice for that variable, the price variable, at t0 the price is 10,000. If I increase by the 10%, right, upside factor is a plus 10%, downside is a minus 10%. So if I increase, if I have in the first year, if I go up, then the value, the price will be 10% more than that, right? So it's the upside factor times the 10,000. If it goes down in the first year, it's the downside factor times the 10,000. Okay. Now in the second year, the price, if it goes up twice, so it goes up from this first year going up, it's this previous year's, and it went up. Now, and you know, if you follow along this top row, it's always going up all the way through. So it's always multiplied the previous year's value times the up factor. If in this second year it actually goes down from the first year, goes down, so I multiply this previous year's value here and multiply times the downside factor. That's the same as taking this value times the upside factor, right? So from year 0 to year 2 to get here, I could either go up 1 and down 1, or down 1 and up 1. Same value, right? Because these are reciprocals. So what's done to keep things simple, I'll multiply by the upside factor all the way along the top row, but everything else, I'm just going to use the downside factor. So I'm going to go from here to here. From here to here. I never use the upside. So this one could be the upside factor times this, but I'm not doing that because it's more complicated. For consistency, all of these values here are calculated from the downside factor times the previous year's higher number. Right? So this one is this times the downside, right? And so on. Hopefully you get that idea. It's much easier to do. You can do it either way, but it's much easier to do it this way for consistency. Probabilities, we talked about this. The formula, I don't know. Do I have the formula here? Hold on. No, I don't have the formula. Maybe I do. Yeah, here's the formula. Formula is 0.5 plus 0.5 times the growth rate divided by volatility times the probability.